Welcome to aminacademy.com. In vector calculus, let us do some introduction. What is vector calculus or vector analysis? It is concerned with differentiation and integration of a vector fields, primarily in three-dimensional Euclidean space. The term vector calculus is sometimes used as a synonym for the broader subject of multivariable calculus. Here it is useful in physics and engineering, especially in the description of electromagnetic fields, gravitational fields and fluid flow, etc. So it is more useful in these engineering fields. A vector valued function, also referred to as a vector function, is a mathematical function of one or more variables whose range is a set of multi-dimensional vectors or infinite dimensional vectors. Here the vector function, if a variable vector a depends on a scalar variable t in such a way that as t varies in some interval, the vector a also varies, then vector a is called vector function of the scalar t. We can write this for example, some vector field a. Vector a can be represented by a of t, the same as f of t. Now a scalar field. A scalar field. A scalar field associates a scalar value to every point in a space. The scalar is a mathematical number representing a physical quantity, that means without direction. Examples of a scalar field in an application include the temperature distribution throughout the space, the pressure distribution in a fluid, and spin zero quantum fields like etc. It deals the scalar field. A vector field is an assignment of a vector to each point in a space. A vector field in the plane, for instance, can be visualized as a collection of arrows with a given magnitude and direction, each attached to a point in the plane. Vector fields are often used to model, for example, the speed and direction of a moving fluid throughout the space. That means this it's helpful to precast the monsoon or the strength and direction of some forces, such as a magnetic or gravitational force, as it changes from point to point. This can be used, for example, to calculate work done over a line. Next, what is vector differentiation? The derivative of a vector valued function can be understood to be an instantaneous rate of change as well. For example, when the function represents the position of an object at a given point in time, the derivative represented its velocity at that same point in time. For example, here delta vector a over delta t, that means change in vector a with respect to time can be represented as like vector a into time plus little change in time delta dt minus vector a of t over delta t. This is a representation of differentiation of vector a with respect to time. Now, then vector integration. A line integral, sometimes called a path integral, is the integral of some function along a curve. Look at this figure. Here, this along, that is an line integral, sometimes called a path integral, is the integral of some function along the curve. One can integrate a scalar valued function along a curve, obtaining, for example, the mass of a wire from its density. One can also integrate a certain type of vector valued function along a curve. That means vector valued function, we can find the value of that vector through some particular curve. For the discussion, we'll discuss in future videos. We have done. Please subscribe our YouTube channel.